So you just got a new smartphone. You're holding it in your hand, that perfect, cool slice of glass and metal. It's a window to pretty much the entire world. You saved up, you unboxed it, and now you're connected. It really feels like the peak of modern borderless technology, doesn't it? But what if I told you that the very existence of that phone, and let's be honest, the price you paid for it, was shaped by a narrow, rugged strip of land thousands of miles away, a place where empires have been rising and falling for centuries. This, right here, is the hidden geography of globalization. Your world, our world, is built on these ancient passages, places like the Khyber Pass, and its story, well, its story is the key to understanding the very real, very physical infrastructure that holds up our digital lives. To really get why a mountain pass in Central Asia has anything to do with the phone in your hand, we have to start with a simple, kind of brutal fact of geography. You see, mountains, they don't negotiate. When nature throws up a giant wall, humanity has to find a door. And for thousands of years, this 33-mile stretch has been the main doorway through the massive Hindu Kush mountains. I mean, at its narrowest point, it's only 10 feet wide. You should think of it less like a road and more like a historical funnel, squeezing armies, traders, and entire cultures through one tiny opening. And that funnel effect is exactly what makes the pass so unbelievably powerful. It proves a simple truth that empires have known forever. Geography is destiny. The Khyber Pass is what you'd call a classic geographic choke point. It's simple, really. If you control that pass, you control who and what gets through. You control the trade, and when you control the trade, you control the wealth and power for the whole region. It is the ultimate strategic high ground. The history here is just staggering. I mean, look at this. Alexander the Great marched his army through this exact pass to get into India. Hundreds of years later, the Mongols swept through the very same route. Then came the Mughals, who used it to build their empire. And then much later, the British Empire fought bloody wars just to fortify it against their Russian rivals. Every single one of those empires, separated by centuries, by different technologies, they all knew the exact same thing. This wasn't just some catchy military phrase, it was a fundamental law of geopolitics, literally carved into the land itself. But you know, the Khyber Pass wasn't just about armies and conquerors. Long before it was a military objective, it was a vital artery for commerce. It was the lifeblood of ancient civilizations. Think about it. Before our world of global logistics, trade was a physical, dangerous, and slow business. We're talking caravans of camels loaded down with silk from China, spices from India. All those precious goods had to flow through choke points, just like the Khyber Pass, to connect faraway markets and, really, to fuel entire economies. And look at the parallel here. It's just incredible. The technology has obviously changed. We've swapped camels for 18-wheelers. But the core logic, it hasn't changed one bit. The goal is always the same. Find the path of least resistance through otherwise impossible terrain. The highways we drive on today often trace the exact same paths carved out by those ancient traders. The stability of these routes was everything. When they were open and safe, cities got rich, cultures mixed, ideas were exchanged. But when they were disrupted by war or chaos, whole regions could just collapse into economic ruin. And that dynamic, it never really went away. It just scaled up. A lot. So let's fast forward to today. We live in this age of hyper-complex global supply chains, right? But that ancient power of the choke point, oh, it's more relevant than it has ever been. Let's go back to that phone in your hand. Its journey is nothing short of a logistical miracle. You've got raw materials pulled from different continents, shipped to factories in Asia to be made into tiny components, which are then shipped to another country for final assembly, before finally being shipped all the way to you. Every single step in that chain relies on a physical journey. And that journey is fragile. So fragile. Remember when that container ship, the Ever Given, got stuck in the Suez Canal back in 2021? It blocked just one modern choke point for only 6 days. The cost to global trade was nearly $10 billion per day. That's the staggering power of a single modern choke point. And the Suez Canal isn't some one-off thing. Our entire global economy hangs on a handful of these critical passages, both on the seas and on land. The Khyber Pass region? Yep, it's still a crucial piece of the puzzle, connecting Central Asia's resources to all of the world's markets. This kind of changes how you think about a simple purchase, doesn't it? You're not just buying a thing. You're buying the geopolitical stability and the logistical success that kept every single one of those routes open, from the mine, to the factory, to the port, to the store. So this all brings us back to the hidden wires of our world. We see everything through these sleek digital screens, but we live in a world that is still profoundly, and yeah, vulnerably, physical. We have planes that fly over oceans in hours and fiber optic cables that move data at the speed of light. We love to think we've transcended geography, but the minerals, the computer chips, the finished products that actually make up our lives, all of it still has to navigate the same physical world, the same mountains and seas that traders and armies dealt with thousands of years ago. You see, the story of the Khyber Pass isn't really just history. It's a map of our present. It shows us that the systems delivering the world to our doorstep are enormous, intricate, and way more fragile than we'd like to think. So the real question isn't if the next choke point will get blocked, but when, and what happens to that phone in your hand when it does. You know, that device you're probably holding in your hand right now, it's a miracle of engineering. But the journey it takes to get to us, well, that's an incredible and surprisingly fragile odyssey. Today, we're going to deconstruct that journey, from deep inside the earth all the way to your pocket, to really understand its hidden complexities. And that brings us to the core question of this whole thing. It sounds a little crazy, right? How can some blockage in a remote mountain pass, thousands of miles away, actually change the price of the phone you're about to buy? To answer that, we have to start at the very beginning. You see, the story of your phone doesn't start in a sterile lab or some high-tech factory. Nope. It begins right here, deep underground, with the raw materials that make all of our modern technology possible. At the very heart of your phone are something called rare earth elements. These are metals most of us have never even heard of, names like neodymium, which makes the speaker magnets work, or dysprosium, which makes the vibration motor vibrate. Without these, the smartphone as we know it literally couldn't exist. They are absolutely essential. But here's the thing that trips a lot of people up. Despite the name, these elements aren't actually that rare in the Earth's crust. The real problem, the bottleneck, is concentration. See, the process to dig them up and refine them is so incredibly difficult and expensive that the infrastructure to do it is concentrated in just a handful of places on the entire planet. And you can really see this concentration when you look at the numbers for just mining. One country, China, is responsible for about 60% of all global production. That is a huge majority. But believe it or not, the supply chain gets even more focused in the next step. Because this is the really critical stage, refining. Even if those elements are mined somewhere else, they often get shipped to China for processing. And here, China's control is just staggering. We're talking 85% of the global total. This creates this enormous vulnerability, a massive choke point, all centered on one single region. So you can start to see the problem taking shape, right? If there are geopolitical tensions or a key transport corridor gets blocked, suddenly getting those raw materials to the refinery becomes a massive challenge. Companies have to find other routes, and those alternative routes are always slower, and they are always more expensive. And that's just the very first link in the chain. Okay, so once those raw materials are finally processed into usable metals and plastics, that's when the real complexity kicks in. We've moved from the source to the assembly line, a process that is quite literally scattered across the entire globe. See, modern electronics are built using what's called a distributed supply chain. What that really means is that no single country makes a smartphone. It's more like a global team effort, where super specialized components are made all over the world and then shipped to one central place for the final assembly. And this global teamwork is truly remarkable. The brains of the phone, the processor, that probably comes from Taiwan. Its beautiful display, South Korea. The incredibly sophisticated camera module, Japan. And then, each of these high-tech puzzle pieces has to be shipped perfectly on time to a final assembly plant, usually in China or Vietnam. This system is a marvel of efficiency. I mean, when it works, it's like a perfectly choreographed global dance. But that razor-thin efficiency comes with a very steep price. The entire system is incredibly fragile. It's built on perfect timing, with basically zero room for error. So what happens when that perfect timing gets broken? What happens when one of those dancers is late? Well, the answer is a catastrophic ripple effect that can bring a multi-billion-dollar industry to a grinding halt. Here's how it plays out. That disruption in the mountain pass means the raw materials are late to the refinery. That delay then cascades, so the processors arrive late to the next factory. And suddenly, that massive final assembly line in China, with all its workers, all its running machinery, is just sitting there, idle, producing absolutely nothing. And eventually, that means the finished phones miss their shipping dates and the store shelves where you buy them stay empty. And when the parts finally do arrive and production is scrambling to catch up, the factories have to make some tough calls. They're going to prioritize their most profitable products, the expensive flagship phones. And the lower cost, more budget-friendly models, they get pushed to the back of the line, which means this whole disruption hits the most price-sensitive consumers the hardest. Now, all of these delays, the idle factories, and the frantic rerouting, these aren't just logistical headaches for some big company. They have a very real, very tangible cost that, you guessed it, eventually works its way down to you, the person buying the phone. The whole philosophy behind this system is called just-in-time manufacturing. The idea is brilliant, really. You minimize storage costs by having all the parts arrive exactly when they're needed, but it has one massive weakness. There's zero buffer, no safety net. A delay of just a few days can be a complete catastrophe. So when that delay hits, companies are stuck with a terrible set of choices. Do they just wait it out, losing money every single day that line isn't running? Do they pay a huge premium to reroute shipments through longer, more expensive paths? Or do they try to find a whole new supplier who will almost certainly charge them more? Every single one of those options adds cost to the final product. So what is that cost? What does it all add up to? Well, studies show that a major supply chain disruption can increase the final cost of that product by a pretty shocking 5 to 15%. That is not a small number when we're talking about something that already costs a lot of money. Let's put that in real money. For a $1,000 smartphone, that 5 to 15% increase means you are suddenly paying an extra $50 to $150. And think about it, you're not paying for new features or better technology. You're paying for the logistical failure of getting parts from point A to point B. So after seeing these vulnerabilities exposed again and again, it's no surprise that companies and governments are now desperately searching for ways to make this fragile system stronger. They're looking for more robustness, more resilience. And the search for these solutions really boils down to a few key strategies. There's reshoring, which is all about moving factories closer to home. There's massive infrastructure investment to build new alternative trade routes. Some companies are even ditching just-in-time and are starting to stockpile critical parts, while others are trying to diversify their suppliers so they aren't so reliant on a single country. But here's the reality check. None of these are a perfect fix. Every single one involves a major trade-off. Building new factories is incredibly expensive and takes years. Stockpiling parts runs the risk of them becoming obsolete before you ever use them. And no matter how many new roads you build, geography always sets the limits. There's simply no easy, cost-free answer here. Which brings us right back to the device in your pocket. It's not just a piece of technology, is it? It's the end result of a mind-bogglingly complex and fragile global network. Its very existence depends on the smooth operation of that system, on the stability of trade routes, and on the geopolitical relationships that keep everything moving. So the next time you see the price of a new phone, remember this whole journey. Remember that the final cost isn't just for the silicon and glass, but for its successful passage through a world of challenges. Because sometimes the price of innovation, it isn't decided in a factory at all. It's decided in the mountains.